Welcome to the September 25th, 2017 Kubernetes SIG Apps. And with that, I will start by sharing the agenda document into chat. My name is Matt Farina, and I guess I'll be organizing this stuff today. If anybody wants to continue taking notes or to help with those, again, in the agenda is where we take notes. And so that should be shared in chat for everybody to see. And the very first thing that we have today is some announcements. Today is the 25th. And so the first one we have is, if you're eligible to vote, now is the time to vote for the steering committee. The vote ends on October 3rd. And then I think it's the Thursday after that, we start to learn the results. If you are eligible to vote, you would have gotten an email saying, here is your personal voting URL that you can go to, and everybody's is different. So you can go there and take your vote. You might want to check if you're using Gmail, it ends up in one of the other folders, or check your spam if you're not sure. But there are hundreds of people eligible to vote, and if you are, please get out the vote. The next one is about testing. If you go look at the Flaky test jobs, we still have one Flaky test job associated with SIG Apps, and here's the name of it. It's the job should run a job to completion when tasks sometimes fail and are not locally restarted. It's listed in the Flaky test jobs file that's linked there. If somebody who's familiar with jobs and the test could go take a look at that, it would be appreciated, because it would be great if SIG Apps was not associated with any of the Flaky test jobs. So those are the announcements for today. The next part, before we get into our main topic, which is doing planning work for Kubernetes 1.9, is we have a couple of demos. And the first one is Kedge, which is formerly known as Open Compose, if I remember right. And do we have somebody on to demo that?
Yeah, hi. I'm Shubham speaking. I'm audible?
All right, great. The floor is yours.
Awesome. I'll start sharing my screen. Can you see my screen? Okay.
I can see your screen.
Yeah. Hi everyone. So I'm Shubham. I work for Red Hat, and me and my team we contribute to KK Compose, and now we have identified a problem area, and now we are writing this tool called Kedge. And I'll just set the context before jumping into the demo. So we identified an area where here the teams inside Red Hat and the folks we work with, they were struggling to do Kubernetes native development. So the way things would happen was, First, the developers would have to learn Kubernetes. Then they needed to learn how to deploy on Kubernetes, and they were not essentially solving business problems. They were actually spending time setting up the infrastructure and plumbing, and a lot of them, resorted to certain tooling. Like, they would resort to the Docker tooling, or they would use Docker Compose to define the multi-container applications. However, that would not scale in production, because the production would be running Kubernetes or OpenShift. And any way of converting between different file formats would lead to leaky abstractions and limiting syntax, and the production folks just won't get enough knobs to turn that Kubernetes provided. Or certain teams would have a container and Kubernetes experts in their team. They would do all the heavy lifting for containers and everything. Rest of the folks won't care about it. So this entire topic of making your application definition easier, deploying to Kubernetes, was also discussed in KubeCon earlier. So that is where we started writing Kedge, and we were really trying to understand how can we make writing Kubernetes applications, defining Kubernetes applications much simpler. So what we've essentially done in Kedge is we have merged, we have moved around certain Kubernetes constructs, certain Kubernetes specs around, and we have added intelligent defaults without taking away anything from the developer or an ops person or a DevOps person, however you want to name it. So what we've essentially done at the root level, so in our YAML, we have essentially merged pod spec and the Kubernetes controller spec. A Kubernetes controller would be, I mean, in 90% of the cases, it would be a Kubernetes deployment. So we merged pod spec and deployment spec. We also support other controllers like jobs, in which we have merged job spec and pod spec, and we auto populate all the other metadata. For example, you don't need to specify, okay, if it's a beta deployment or it's batch v1 job or something like that. We'll just take care of it. Plus, we have added certain shortcuts that we identified. So while working with teams here, we identified certain patterns that were getting common in application definition. So we were always like, okay, how do we save you guys a couple of levels of indentation? How do we make your YAML concise and more intuitive and all of that? So that was the basic idea of Kedge. Right now, what you see on screen is, so someone who is just getting started with Kubernetes, right, an application developer, all he or she would need to write is something as simple as this. So it's just your application name, the container image that you're going to use, and the service. So at the very root level, what you see is this entire containers field, right? It is essentially part of pod spec. So whatever you can define in a pod spec, you can define here. Under the field services, that is again service spec. So whatever you can do inside a service spec, you can define here. But if you guys remember the shortcuts that I was talking about, so we added certain shortcuts. For example, in this case, it will be port mappings. So instead of you having to write ports and then name the port, then target port and normal port, then protocol, you can just define that in one line using port mappings. And you can just give target port and the protocol there. However, since this is a vanilla service spec, you can always define your ports the long way as well. So we are not taking anything away from the Kubernetes spec in any way. We are only appending things to do it and just restructuring the entire thing such that it's better suited for application definition. I'll quickly jump over to the demo. So right now, what we just saw, that was a very simple application, but over time, like when we say that Kedge is actually Kedge actually goes into your CI/CD and all of that, which means that Kedge is totally production ready. That would mean okay. So here for our demo, we have this full blown GitLab example. As you see on the screen. We have 3 files in the root. One is GitLab, another is Postgres, another is Redis. So what we follow essentially in Kedge is, your one Kedge file, one file should be able to define your one microservice. It can be handled, appropriately by teams. So for example, if one team wants to take care of GitLab, okay, all you need is that one file. So just go develop that service. Everything, all the Kubernetes constructs that you need for GitLab, or you need for Postgres, or you need for Redis, it should be in your respective files. I'll quickly show the GitLab file. So like I told you guys earlier, this is again pod spec and deployment spec merged at the root level. So you see something very familiar. This is all vanilla Kubernetes, but again, all the levels of indentation, all the metadata is totally gone. You just need to take care of defining your application. You see, fields like replicas. This is coming in from the deployment spec. Field container. This is coming from the pod spec. This is all very simple, and I mean, they're very, very similar, very much more intuitive. Environment variables are the way they should be. So we have added certain shortcuts. Another shortcut that we have added would be health. So we noticed a pattern in which liveness probes and readiness probes would be the same for a lot of applications. So we added this shortcut called health, which is, I mean, inside inherently it is leveraging on the same definition of a Kubernetes probe, the liveness or readiness probe. But when you define something with health, it generates both liveness and readiness probe with the same values, because that was a pattern that's common to a lot of applications. However, since this is all vanilla Kubernetes spec, you can define both of them different. You can set different initial relay seconds for both and all of that. So that's one shortcut that we've added. As we come down the file, we see that these are the Kubernetes services that you've defined. I showed you guys. So see, this is again, service spec. So you see type, load balance, and all of that coming in from the service spec. What you see here is port mappings, which I showed you guys earlier. So you don't need to write the full-blown ports. However, you can define it like this, which is the standard definition. However, if you notice, there's a new line called endpoint here. Again, we have appended this shortcut to the service port. What this would essentially mean is this will just by adding this one line, just by writing endpoint, Kedge is going to create an ingress resource for you. All the required information is going to come from the port here and the service name there and all of that. So yes, so you can define your ingress resource like this. However, if you want to define an ingress resource separately, you can do that at the root level just by typing in ingresses and followed by an array of ingress spec. That's one thing that we have added. Then we have volume claims the way they should be. Then we have secrets, config maps, a full-blown production-ready GitLab application basically. I'll quickly get out. Again, we have to, so GitLab requires two other things, Postgres and Redis. Again, I'll quickly skim through the Postgres file, all the same environment variables. Again, we see health is there and CPU resources, volume mount, services, volume claims, secrets, all of that. Redis should also look relatively the same. Yeah. So all you need to do is now just run Kedge create on this directory which contained all of the files. Oops. Okay. Before that, I'll just create a new namespace, GitLab Live. I will switch to it. Yeah. And now I'm going to do a Kedge create on the directory which had all my Kedge YAML files. You can see that all of those things are live getting generated and deployed to the cluster without any leaky abstractions because it's all Kubernetes in the end, without any limitations. And okay, so this thing has been deployed, but I just quickly want to focus on one thing. If I quickly do a line count on all of the YAML files present, which means these three Kedge definitions that you just saw, this was 180 lines of essentially, I mean, Kubernetes spec that we had to write. Kedge generate is a command which just generates the artifacts that's not deployed to the cluster. I will do a line count on this, and the line count is 411. That is from 180 lines of no leaky abstraction defined application using Kedge. You generate 411 lines of Kubernetes code, Kubernetes application definition, Kubernetes artifacts. I quickly show the output that Kedge generate shows. You can see, okay, PVCs were generated like the way we defined in a file. I'll quickly grep for ingress. You can see just by specifying that one line endpoint, the entire full-blown ingress resource was generated. We quickly take a look at liveness probes. So using the health shortcut, you can see that both liveness and readiness probes were generated, all of that. So this is where we see, Kedge adding a lot of value. Now GitLab is going to take some time to come up. So I actually deployed it in another namespace before. So I'll just do kubectl get pods. It's running. I quickly go to this URL. Okay, sorry. Quickly check if it's working. Yeah, so GitLab is up. Another thing that we could do is, so By default in Kedge, the Kubernetes controller that we assume that you want to provide is the Kubernetes deployment, which is which is the most common controller in 90% of the cases. However, you can also define different Kubernetes controllers, and we believe that one controller should be able to define your entire microservice in its entirety. So what you see in this definition, it's just a Kubernetes job. Again, you see job spec and pod spec merged, and we have added a field called controller, based on which we generate the Kedge artifacts. So this is a small job which is just going to run, and it's just going to create a user in the GitLab that we just did. We'll just log into this. I'm in GitLab. Under admin area, we don't see any user right now. Right, we don't see any user. So what I'll do is I'll just do a Kedge create -f on this Kedge definition of a Kubernetes job, and the job was created. It's running. I hope something comes up. By the time the job executes, I'll quickly show you that just by writing those few lines, Kedge generated this entire Kubernetes job, which was then deployed to the cluster. Let's see if the job was, yeah, the job was successful. If I refresh, I should be getting, yeah. So we have a new user. So I mean, yeah, Kedge actually works. Okay, that's more or less about the demo. I'll quickly go to the presentation again. And okay, so that was the demo. So just to give a visual angle to this, what you see on the left are the Kubernetes resources that your developers or your production folks, or I mean, anyone would have to write just to define a simple WordPress application. What you see on the right is the same definition same definition written using Kedge on the right. So on the right, there's Kedge, and what's on the left is your standard Kubernetes definition. So like we have spoken about most of the things, it builds on top of Kubernetes. There's no DSL, there's no leaky abstraction. It's merely a rearrangement of Kubernetes spec to suit application definition. It adds shortcuts, it enriches the end user experience, and it's built for dev and prod. It does not limit the end user in any way. It adds intelligent refalls, autofills the metadata. What else? So we support multiple other shortcuts. Health and endpoint just happen to be one. So some of them we have shortcuts for volume mounts and other stuff. We also support external Kubernetes resources. So let's say the stateful set controller is not yet supported by Kedge. Then just by specifying a field in your Kedge YAML, you can link it. You can link your Kedge definition to an external Kubernetes resource, which will be essentially a file. So I mean, you're not limited in any way. So Kedge is actually going to parse that thing and feed it to Kubernetes. So you can actually provide any Kubernetes resource, all the if you want to do third party and all of that. What's next? So LSP integration with VS Code, Eclipse, that's in the works. My colleague Suraj is working on it. Then we are looking into integration with CI/CD pipelines for stuff. And yeah, that's about it. So Charlie, a colleague of mine, he created a very beautiful website at kedgeproject.org. Go visit it. Then we talk on GitHub, we talk on Slack, and the application that I demoed, the GitLab thing, you can find it at my repo. GitHub contains Kedge demo. Awesome. That's about it. Any questions? Thanks.
Thank you very much. Yes. Does anybody have any questions about this? I quite like what I saw. Thank you. All right. Wonderful. Then I guess we're on to our next demo, which is a Terraform Kubernetes provider. Do we have somebody on to talk about that?
That's me, yeah.
Fantastic. The floor is yours.
All right, so before I do the demo, I'm just gonna share a few slides. I'll try to keep it very brief and leave some time for questions. Oops. All right, so you should see the slides, hopefully. Let's see. So my name is Radek Simko. I work for HashiCorp, and we make a tool called Terraform. And obviously, I don't want to convince you that like Terraform is the only way to provision your Kubernetes resources. Neither is any other way. But I'll try to describe the context in which it may be useful. So Terraform is basically a multi-provider tool which allows you to manage your infrastructure as code. And by provider, we mean different things. You can manage resources like traditional resources like VMs in cloud environments like AWS, Google Cloud, Azure, OpenStack, etc. Or DNS, or even other things which are related to your infrastructure like PagerDuty schedules, Datadog monitoring, Bitbucket or GitHub repositories, or users, or things like that. It has a pluggable architecture where binaries are talking with each other over RPC protocol. And the generic aim is to allow the users to control their infrastructure, like typically network, build out their networks, firewall rules, VMs, autoscaling, S3, etc. Now, before we talk Kubernetes, people or the existing users of Terraform generally perceive Terraform as a tool for managing one particular part of the Kubernetes cluster. So let me decompose what it means for me to manage Kubernetes cluster. So before you start, you need some kind of basic infrastructure, whether you run on bare metal, that's iPXE, or in the cloud, it's AWS, Google Cloud, or anything else, VMware. And then on top of that, you expose the interface, which basically means you have a running operating system, your Linux flavor of your choice. And on top of that, you typically have some kind of configuration management like Puppet, Chef, or Ansible, which typically involves things like setting up things like etcd, kubelet, the API server, the CA certificates, and things like that. And then finally, you get to the top layer, which is the Kubernetes API. And what I'm going to talk about mostly is the top layer. So Terraform was historically perceived as a tool to manage the lower layer, which is still the case. But the provider that I'm talking about is focusing on the top layer. So one first thing to understand in Terraform is that Terraform has its own language, HashiCorp config language, and setting the option of manual management of your resources aside, because that usually doesn't scale. If you're not using Terraform, you would be building your own scripts in a high-level language, something like Python or Go, and you would be basically using sort of the imperative approach, and you would be dealing with the idiosyncrasies of APIs and things like that. On the other side, you could use languages for data, like JSON or YAML. And the high-level languages typically allow you, they offer you a lot of ways to shoot yourselves in the foot. You know, they have classes, abstractions like functions, and things like that. And on the other side, languages for data lack these features, which makes them very simple, but at the same time, they also lack features which you may find useful when describing infrastructure, like referencing or comments. I mean, there is referencing in YAML, but if you ever played with it, like, it's not very convenient. So in the middle, we have the DSL. And Terraform, as well as Puppet, has chosen this path, despite the fact that designing a DSL is quite a challenge. So HCL, you can find it on GitHub. It is used in various GitHub projects like Console, Vault, Nomad, or Terraform. And it is JSON compatible, which is useful for in case you want to generate the code. Now, before I finally jump into the demo, I just want to explain what kind of workload do we expect people to run through the Terraform provider in Kubernetes. So at the moment, we support pretty much all V1 resources. There's 13 of them, which you can see, and 2 data sources. And you can certainly, we would recommend that people use those resources, those sort of ops-focused resources like config maps, limit ranges, resource quotas, secrets, namespaces, service accounts, because operators are usually the ones who may be already familiar with Terraform and the syntax. So it is a natural sort of overlap. Now, Terraform also supports the workload, so-called workload resources like pod or application controller, the pod autoscaler. And a good use case for those resources is managing shared services like logging, monitoring, etc. Anything that you would set up on top of a running cluster as an operator. You may ask why. So Kubernetes has this concept of admission controllers, where the controller can intercept any request and modify the resource on the fly, modify the resource which you are trying to create. And that kind of may conflict with the config and generally the way Terraform tries to manage the resources. And I'll show you later how. So it's okay to use Terraform for scheduling applications, but as a developer, you may not know about these admission controllers the operator has put in, which may cause some confusions. So finally, we have demo. Yay. Okay, let me switch my screen. Right, so what we have here. Okay. Here we go. So what we have here is a provider definition, which says to which cluster to connect to. That's basically the config context. And then we have a replication controller and a service. And here we have basically translated the HCL definition to, or the other way around, basically translated the API Swagger definition to the HCL, to the schema here. So you can specify the spec of the controller here, and the template, which has the container and some limits and requests. And then we have the service with some details and output, which allows the user to see the service name in this case, so that they can leverage it elsewhere, or just generally see it in the console. So coming back to my terminal, I first need to initialize Terraform, which would normally download the Kubernetes provider in this case, but I already have it, so it didn't do much. And then the nice feature of Terraform is the plan. It may not seem as useful at this point since we are just creating 2 new resources, but I'll show you in a second how that's useful when you have an existing infrastructure. So we have just created the replication controller and the service. And now what I'm going to do is that I'm going to change something in the config. Let's say I want to change the port. So I want to expose it to 80. Yeah. And now I can run Terraform plan, which basically tells me, hey, you're trying to change this thing here. So this is the difference between your config and the reality. It's also useful. What you may not have noticed is that we actually checked the API to see what the reality is before showing the div. So if someone has changed this port or anything in the definition of the service, then it would appear here. And the other reason why this is useful is because not every resource is, or not every change, not everything can be changed basically. So let's say if I change the type of the service to cluster IP, and then I want to define custom cluster IP, which is typically not like a mutable operation. It's not a mutable field. Then Terraform is aware of that fact, and basically it will tell me, hey, you're just trying to change the cluster IP, and I can't do that, so I'll recreate resource for you. So be aware that this may be a disruptive operation. So that's that. I think that's pretty much what I wanted to cover. So are there any questions?
I have a question.
Mm-hmm.
So my understanding of Terraform is that it keeps state locally in order to actually create the plan. But you showed it querying the API server. How much of the state is being managed by Terraform, and how much is actually being managed internally in Kubernetes?
Right, that's a good question. So we make the distinction on the API level. So obviously, if you're scheduling a replication controller, then Terraform won't deal with the state of those pods, which are scheduled by the replication controller. So it should, I think the distinction is there on the API level, basically. If, I don't know, if you're, there are some overlaps, obviously. So if you have like the autoscaling, the pod autoscaler, and then you have the replication controller, then I think the autoscaler itself is fine because it remains as is during the autoscaling procedures, but the replica set will obviously bump up or decrease the number of replicas that are running. And that will be reflected in the API as well. So I think there are ways to avoid that overlap as well. But I don't know if I'm answering that question. Did I answer your question?
A little bit. I guess I'm asking like what state is actually kept locally versus what is in the cluster. It seems like a lot of it is in the cluster. So what actually is currently your machine?
It's in both places, I believe.
Mm-hmm. But what's the distinction? What gets stored locally, synchronized locally versus relies on cluster?
So the recommendation that we give to Terraform users is to always store the state remotely. Either way, especially if they work in a team. But by default, if you don't do that, it's stored locally, and I can show you what's in there in a second. So it basically it's anything you find, anything you get from from the API, as you can see here.
So if I run Terraform plan, it is only going to hit the API server, but even if it can't hit the API server, it's going to use the local state.
So if it can't reach the API, it will probably error out, but you can pass in a refresh equals false, in which case you tell Terraform to do not do the refresh. So you basically acknowledge that you may have an out-of-date state, and the plan may not be accurate due to that. But yes, you can do that.
Okay, awesome. Thanks. That clears up a lot of things.
Any other questions?
All right, thank you. Thank you for the demo. If folks have questions, please feel free to either ask them in the chat window as we continue going on here, or reach out to folks offline. So the next thing that we have is 1.8 is slated to come out this week. And so we're starting to slide into 1.9 planning so we can hit the ground running. There's some 1.9 planning that we can look at what's inside of Kubernetes itself, and then there's some ecosystem stuff that we can look at and talk about as well. That'll be happening in the same time frame. To kick that off, there's a link to a document, which is the 1.9 planning document. It's linked in our stuff, and I'll drop the link into chat here, and then I'll share my screen, and we can start talking about 1.9 planning. Let's see. All right. Can you let me know when you can see my screen?
We can see it.
Fantastic. So what I've opened up is a 1.9 priority planning document, and we can add columns for companies as it's needed, or add other details. I ask folks, even after we continue today, to please fill this out. In the next few days, I'll also be looking over the 1.8 planning document. In fact, I can share that as well. We had 2 documents on that, the 1.8 planning. And we'll be revisiting what we ended up accomplishing. Oh, where's my... I'll drop that in a minute. It seems I've lost my window to share things. And in the 1.9 planning, I wanted to make a few notes here. When it comes to Kubernetes core, there's some things, daemon set, deployment, replica set, stateful set, that are currently v1 beta 2. We'd love to get these things to stable in 1.9. And so if folks want to work on stability issues more than features, we'd love that, because it would be fantastic if they were stable parts of the API rather than v1 beta 2. And this is a new group for them to be in Kubernetes 1.8 that's coming out this week. They've moved there, and so now stability is a big thing. Some of the other things, let's see, app registry has requested going through incubation. We'll need to, as I understand it, wait for the steering committee, those elections that I asked everyone up front to get involved in, before we look through what would happen for incubation, because the steering committee has to make some decisions and calls there. I'm not even fully aware of what that would be yet, but it has requested it. So those are the notes. And I'm also not sure, like, for example, one of the things that has been coming up in some of the meetings is how long after a version of Kubernetes comes out does some of the supporting tooling such as Helm come out to match that? And I'm not sure. I think Helm 2.7 is the next release, and I'm not sure when that's going to be out. If somebody has more detail, it would be fantastic. But I noticed that a lot of the Microsoft folks are not on today. So with that, though, that's what I've got. I see the Koros folks have added a create first rolling update. There's a proposal in for that to be part of the daemon sets. If anybody's not aware, this is, if I remember right, this is about create first rolling update. That's where you create it and then you destroy the old one. Is that right?
Yeah, that's correct. This is Ryan from CoreOS. Yeah, there's some issues that we need to talk about with the design doc, but we'd like to see this at 1.9.
Okay, great. If folks are interested in jumping over here, the link in there is to the design proposal for it. And so you can read it, read the commits and the discussion on it. So 1.9 planning. Who's got what to say or to fill in your name or your organization's name where somebody's going to be attacking a particular thing within this? Floor is open. So maybe one of the things I'll start with, does anybody know what's going on with defer containers? I've heard a number of things. There is a work in progress pull request to implement some details around like there's the pod termination semantics, which is one of the things defer containers do. If you don't know what defer containers are, in the Go programming language, there's the idea of defer a function that'll run when the parent function ends. And that's the idea with defer container. So my thing ends, and so here's something I'm deferring to fire off or clean up or whatever, compared to other ways that you can do it. And that's what defer containers are. It takes that same idea here. Does anybody have any details on that? Is it even coming? Is that something that should be worked in 1.9? Sounds like nobody's got a whole lot to say about planning. Can I stop sharing my screen for a moment to see if I could get to text chat here? Does anybody have any comments on this? Or is this something that folks would rather go take a look at for, say, the next week or two and jump in here and add details as we go?
I feel like this is something where we should share around links, have people update the doc, and then do like a brief review process in the actual meeting.
All right. Sounds good to me. So now this document is out there. Feel free to, if your company name is not listed at the top there, feel free to go ahead and add it. And what we want to do is just like, let's see, with the 1.8 planning that we had, in fact, I'll share that document in chat here and I'll link it into the meeting minutes for it. You'll see that there were folks signed up to do it, and then we even tracked if anybody was going to do a row. So there was an idea of doing suggestions and then seeing what was going on there. And then seeing if anybody picked it up. And so we'll actually go through, and I added a column, wasn't implemented, and we'll go through to see what was implemented and what wasn't, but I haven't had the chance to do that yet. And so I'll add links to around here to try and cross-link all of this stuff so it's a little bit easier to find. But please, if there's something that you think you or the company you work for is going to go work on, please let us know so we can try and track this stuff. So with that, since it's quiet and we've got about 13 minutes left, I'll open the floor up. Is there anything that anybody wants to talk about? Any other topics? It's open discussion time.
Hi, my name's Josh. I released a project last week called Chart Museum. I just want to let you guys know I signed up for a demo for next Monday. So if you're interested, I'll be giving a presentation on that.
For anybody not familiar with Chart Museum, it's a project that provides an API for putting and pulling packages from a chart repository and generating your index.yaml file, those things. And so where the app registry, which we talked about recently, is more of a Docker Hub style, where the current implementation in Helm is maybe more similar to Debian, this takes that back-end server-side element that's similar to Debian and puts more API semantics on it. And so it's within that flow of what Helm does today.
Thanks for providing a good explanation there. Yeah, I put a link in the chat. So if you guys have any issues using it, please file an issue, and look forward to talking on October 2nd.
Yeah, we look forward to it. Thank you. Well, if there is nothing else, I can give everyone 12 minutes back. Anything else? Going once, going twice, going 3 times? All right, folks. Well, have a wonderful week. You can find us online in Slack in SIG Apps if you've got continued questions. And please go vote and fill in any planning stuff into the docs. Otherwise, have a wonderful week. And with that, I'm going to stop recording and end the meeting. Thanks, everyone.